Okay, perfect. Excellent, excellent. So, today we're going to be learning about lambda expressions, and we have a lot of great examples to run through, and I think you're really going to enjoy this. So, looking at the syllabus we see today is all about functional programming. And then there's an important note, last day to withdraw with a W. That's coming up. Now, we we definitely have done lots of things in this class so far. We've had lots of assignments on Freer School and Memer and an exam, which also was online because this is a fully remote class. Um, and so you've gotten an opportunity to just do many, many different assignments. And we're going to keep doing many assignments all the way through December. But there are times when you sign up to take a course and lots of things are happening in your life that just make it impossible to keep up with everything. And that's why W's exist, right? It's so you can just sort of quietly walk away from the course and say, okay, it was too much this semester, but in the future, you can retake it. And I mean, there's a penalty to it, of course, right? It's not like a W is the greatest thing in the world to get. It shows up on your record, and then there's the cost involved of taking the course. But for some students, that's not a bad alternative. Um, I don't think it's going to be huge numbers of people running for the W, but you know, some people will take the W, and that's okay, right? So just a reminder that that's an option for the course. Next class, we'll also do some GUI programming with NetBeans, and I'm always looking for a new way of doing this, but for right now, I think NetBeans is still the way to go. So before next class, if you could just install NetBeans, that would make life a lot easier. So let me just put a little note here. So before next class, please install NetBeans. Not that it's a super difficult thing, but if you haven't installed an IDE all semester, this is a good activity. Okay? So I will use NetBeans for it because I've just used it for so long and it's so simple. Um, JetBrains does have a good Java IDE, and they they do have a GUI builder also, but I think I have examples already written with NetBeans, so we'll just use NetBeans as well. Okay, so the let's jump into the course material. So lambda expressions. This is a new feature, relatively new, right? Um, I'm calling JD8 JDK8 new, and we see JD8K came out in, let's see when it came out. JD8K, when did it come out? JDK8. Let's see, JD8K, when did it come out? Let's see if that gives us the answer. No, that's not it. That's J2SE. That's way not. But maybe this will help. Let's see. Java version history. Okay, there we go. So it came out in 2014. Java 8 came out in 2014. All right. And basically, it's going to have support until 2030. Okay, support until 2030. So there are projects that are going to have a long lifespan, and projects will go on even after that. Not every project is updated because there is a huge cost to rewriting software. Okay? So let's see on this list what's the most recent version. The most recent version is Java that we experienced, which is Java SE 17. So that came out during this class in September. Java SE 17 came out in September. And it looks like they have planned for March 18, September 19, then March 2023, 20, and on and on and on. So Java does have a lot of releases, and the language changes with each release, right? So Lambdas didn't exist in Java, and now they do, right? So it's up to the programmer. Do they adopt these new features? Well, it's a good idea in order to adopt new features because there's a reason language designers went to all that trouble to put them in. They have advantages, okay? So what's the disadvantage to new features? Well, you have to learn how to use them, and that takes time. So there's time involved in learning new skills, but the syntax may be cleaner, and the code may even run faster. It depends on what you're talking about. So that ties in the Java version history with what we're about to learn. So an anonymous class. Okay, so we've seen anonymous objects. Anonymous objects were where we make with a new object, but we don't give it a name. Let me remind you what an anonymous object is. So let's go back here to Replit, and we'll create the REPL with Java, and we'll just create this Replit. Okay, so we have here this class main. And we'll say main has public, final, or we'll just say public, I don't know, int I equals 10. Okay, so down here, we can say new main I. And then we can just print it out. System.out.println I. Okay, so we can copy this here, we can paste this here, and we can run this here. And we see it's 10. And what's the reference variable to that main object? There is no reference variable to the main object. So you could say that's an anonymous object. Okay? That's an anonymous object. All right? So let us continue with this example here. So the anonymous classes can be, well, implemented pretty simply, and we're going to get into what's an anonymous class by clicking on this link here. Anonymous classes enable you to make your code more concise. They enable you to declare and instantiate a class at the same time. They are like local classes except they do not have a name. Use them if you need a local class only once. Okay? So, when local classes are class declarations, while local classes are class declarations, anonymous classes are expressions, which means you can define the class in another expression. The following example, Hello World Anonymous Classes, uses anonymous classes in the initialization statement of the local variables French greeting and Spanish greeting, but uses a local class for the initialization of the variable English greeting. All right, so we're used to public class, Hello World Anonymous classes, right? This makes sense to us. And then we have an interface. An interface is a contract, and the contract says if your class implements this interface, it has to deal with every method inside. Okay? If your class implements this interface, you need to have all the methods listed. So you need greet, you need greet someone, and how you do it is up to you, but you need them. Now here inside of say hello, we are going to have some inner classes, right? This is going to be a good day to introduce inner classes. Inner classes are created inside existing classes. So lots of new material today. So inside of public void say hello, we have class English greeting implements hello world. We're going to have a name, which we're going to set to world. And then in greet, we're going to greet someone with world. Public void greet someone takes in a someone through a string, sets name equal to someone, and then we have system.out.println hello name. Okay? So now for the English greeting, we say hello world English greeting equals new English greeting. Hello world French greeting equals new hello world. Now, notice how the hello world French greeting is implemented. It's a little bit different. It's still pretty cool. Okay? So the hello world is going to be this interface. Okay? You implement the interface, hello world, with new, and then inside of there, you're going to set greet, and you're going to set greet someone. Okay? So French do it differently than the English. Okay? The English greeting is an inner class. The French greeting is making the interface, instantiating the interface. The Spanish greeting is going to be the same way as the French, which makes sense because they're both Latin languages, right? Of course, this is just an example. So we see inside Spanish greeting, we've got the name, we've got the greeting, we've got the person they're going to greet. And now we can call the English greeting, the French greeting, and the Spanish greeting. And they are all going to work properly, right? This code works. But it does show two different approaches. So now we see inside the main, everything gets started. So we've got public static void main. And it's just another way you could write the string array args. The ... works the same. It's a variable argument. So it works just like the array of arguments. And then you just make your outside class into an object, and it's going to be called my app, and it's going to be equal hello world anonymous classes, which is the outside class, right? And then we're going to say my app.say hello, and then inside of say hello are all these other greetings, right? And like here is English greeting that we can copy and paste into our code. Okay? So this is just a little more about anonymous classes. An anonymous class is an expression. The syntax of an anonymous class expression is like the invocation of a constructor, except that there is a class definition contained in a block of code. Consider the instantiation of the French greeting object. So we've got our hello world interface, and then we're going to set specifically the details about how the French greet each other. So the anonymous class expression consists of the following: the new operator, the name of the interface to implement or a class to extend. In this example, the anonymous class is implementing the interface hello world. Parentheses that contain the arguments to the constructor, just like a normal class instance creation expression. When you implement an interface, there is no constructor, so you use an empty pair of parentheses, as in this example. Okay? So there's no constructor, we're just using the empty parentheses. Okay? So they give some rules about what you can and cannot do inside of here, right? You can declare the following in anonymous classes. You can have fields. You can have extra methods, even if they do not implement any methods of the supertype. They can have instance initializers, and you can have local classes in there. Okay, but there are no constructors in anonymous classes. Now, today also works because we're going to see a little bit about GUI applications, and then next class we're going to continue with these great GUI applications. So consider the Javafx example hello world.java. So for hello world.java, we are going to have a lot of imports, and then we're going to have some data that we have to set. Like we have to set the button, and then we have to set the title for the primary stage. I guess I first should have said the title for the primary stage. And then the text for the button is hello world. And now look at this. The button on action is going to have a new event handler with an action event. And then we are going to have this method called handle where we can say hello world. So it's kind of interesting how we are making this new event handler inside of this method call set on action, and it just makes life easier to do these sort of things when you're making GUI programming. Javafx is really powerful. I think some of you would really enjoy looking into Javafx. All right. So if we continue down, we can see some more sample code with Javafx. And we can see here's a new text field. And then inside the text field, we are going to have replace text. And then we're going to have replace selection. And pretty long example, but kind of interesting. So let's jump back to Lambda expressions. So we are going to see code that would have taken many lines to write. We are now going to have a shorter solution. Suppose you are creating a social networking application. In case you're just joining us, this is the link that we're on, Lambda expressions. You want to create a feature that enables an administrator to perform any kind of action, such as sending a message, on members of the social networking application that satisfy certain criteria. The following table describes this use case in detail. So, the field and the description. We're going to have the name, performed action on selected members. The primary actor is the administrator. The preconditions are that the administrator is logged into the system, and the post conditions are that the action is performed only on members that fit the specified criteria. Okay? So we're going to just skip down a little bit, and we see that we have a class person. Now, inside of person, we have some rules about sex. Okay? One of the rules is you can only be a male or female in this example. Okay, and this is done using an enum. Enum is short for enumeration. Enum is short for enumeration. So it's going to be listed as either male or female. We're not giving any sort of ambiguity about it, but they do allow gender to be. Oh, never mind. No. They called. I understand. Okay. So the name of the enum is sex, but they called it gender. Okay, that makes sense. All right. So then we have here the name, the local date for the birthday, the email address, which is a string. Now we have a getter for get age, and then we have print person. So it says, suppose the members of your social networking application are stored in a list, and all the list can contain is many person or one persons. One person or many persons. This selection, or this section rather, begins with a naive approach to this use case. It improves upon this approach with local and anonymous classes, and then finishes with an efficient and concise approach using Lambda expressions. Find the code excerpts in the example rooster test. So first, we are going to have many methods. Each method searches for members that match one characteristic, such as gender or age. So this following method prints members that are older than a specified age. Okay? So we've got print persons older than. We send in a list, we send in an age, and then as we loop through, if a person's age is greater than or equal to an age, then we print a person. Haven't we seen examples like this throughout the course? I mean, not exactly with social media, but I mean, you have an array list, or we'll just say list. You have a list. You loop through it, and you print out certain data. That's fairly common, right? But look at this comment. This approach can potentially make your application brittle, which is the likelihood of an application not working because of the introduction of updates, such as newer data types. Suppose that you upgrade your application and change the structure of the person class such that it contains different member variables. Perhaps the class records and measures ages with a different data type or algorithm. You would have to rewrite a lot of your API to accommodate this change. In addition, this approach is unnecessarily restrictive. What if you wanted to print members younger than a certain age, for example? Okay, so you could make a more generalized search where you send in the low end and the high end. But then what if you wanted to specify other filters, like gender or, whatever, a combination of the two? So one thing you can do is you can specify the search criteria code in a local class. So the local class checkPersonTester is going to be whatever you're looking for in a person, okay? So this method is going to check each person instance contained in the list parameter roster, whether it satisfies the search criteria specified in the checkPersonParameter tester by invoking the method tester.test. If the method tester.test returns a true value, then the method printPersons is invoked on the person instance. All right? So, to specify the search criteria, you implement the checkPerson interface. Remember, an interface is a contract. You have to have this method test if your class implements this interface. So what do we see down check person eligible for selective service? We see it does implement test because it implements check person, right? Test is dealt with inside of there, right? So what does test do? Test compares the sex and the age. And in this case, the selective service, you have to be a man and you have to be between the ages of 18 and 25. Now, I think selective service became more inclusive. Let's look it up for a second. Rules for selective service. Let's check it out. Of course, now my Google is being slow. Rules for selective service. What? Google DNS cannot be found. That's odd. But yet I'm still streaming. Nobody's complaining about lack of streaming. No internet. Uh-oh. How can that be? Am I still streaming? Oh, there we go. Okay, so selective service. Almost all men who are age 18 to 25 who are U.S. citizens or immigrants living in the U.S. are required to register with selective service. Okay. So I thought there was something with women were being added too, but I guess that was not true. Okay. So maybe that was just like a rumor I read or something. All right. So we can go back here. So to use this class, you create a new instance of it and you invoke the print persons method. Okay? So we've got print persons with a roster and a new check person eligible for selective service. So now we're getting less brittle, but they still think there could be a better way of doing it. So now we can do specify search criteria in an anonymous class. So one of the arguments of the following invocation of the method print persons is an anonymous class that filters members that are eligible for selective service in the U.S., those who are male and between the ages of 18 and 25. Okay, so for print persons, we've got a roster, which is the list, and then we've got this check person, which is going to have what we're going to filter based on. So inside of check person, we're going to deal with the test, where we take in a person, and we're going to say, okay, return if the gender is equal to male, and if the age is greater than or equal to 18, and less than or equal to 25. Okay? So this does reduce the amount of code required because you don't have to create a new class for each section you want to perform, but they're saying it's a little bit bulky, right? So what have we been leading up to? This whole discussion, now we're many minutes in, we're looking for Lambda expressions, right? That's the name on the syllabus to give us some order. We're looking at Lambda expressions. But in order to get to this Lambda expression, we have to go through a lot of other material to get to this point. So here we are at the Lambda expression. That's the heart of the Lambda. That's the heart of the Lambda expression. All right, so that's going to be really, really the key to understanding all of this. So here we have the check person interface. It's a functional interface. A functional interface is any interface that contains only one abstract method. A functional interface may contain one or more default methods or static methods. Because a functional interface contains only one abstract method, you can omit the name of the method when you implement it. To do this, instead of using an anonymous class expression, you use a Lambda expression, which is highlighted in the following method invocation. So we have print persons. We're sending in the roster, which is a list of people. And now we're going to say, okay, for this particular filter, what we're looking to do is we're looking to call this one abstract method, which is going to be test. So basically, the way I would put it in my words is the arrow operator will call the abstract method inside the interface. Okay, so in this case, it was test, right? Well, let's scroll up and look. Yes, inside of check person, inside of, where is it? Where's the interface? There it is. Yes, inside of check person, we have test. Okay? So inside of check person, we have test. And when you call the arrow operator here, what you're doing is you're saying, all right, for this particular operator, right, for this person, what we're going to do with this person is we are going to call test. So we're sending in the person into test. We send person into test. And then once the person is inside of test, what are we checking? We're checking to see, is the gender male and is the age greater than or equal to 18, or is the age less than or equal to 25? So it calls the method test. So this is the Lambda approach. This is the Lambda approach, or the functional approach. This is called a functional approach to programming. So let me ask you a question. When solving problems in Code Wars, haven't you seen this code, this type of code? Because I'm sure you've looked over some of the other answers when you finish a problem, right? Well, maybe you haven't noticed it, but if you do solve some problems, you will maybe see that. Okay. So they give more examples here. They say use standard functional interfaces with Lambda expressions. So we have here the check person interface as the single method test, takes in a person and returns true or false. This is a very simple interface. It's a functional interface because it contains only one abstract method. This method takes one parameter and returns a Boolean value. The method is so simple that it might not be worth it to define one in your application. Consequently, the JDK defines several functional interfaces which you can find in Java util.function. For example, you can use the predicate interface in place of check person. This interface contains the method Boolean test. Okay? So what does T represent? Well, up to this point, T had represented person, right? We had been sending in a person. So T is just a generic interface, okay? So if you would like to learn more details about generics, you can click on this link. For right now, we just say that whatever you put between the angle brackets, that's what you're specifying the data type to be. Okay, so if you're working with people, you say interface, predicate, person, Boolean test, person T. Okay, this parameterized type contains a method that has the same return type and parameters as check person, Boolean test. Consequently, you can use predicate T in place of check person, as the following method demonstrates. Okay. All right. So here we see print persons with predicate. We get a roster, and then we check to see is P get gender equals sex male, is get age greater than or equal to 18, is get age less than or equal to 25. Then we see another way you can do this. So, reconsider the method print persons with predicate to see where you could use the Lambda expressions. So we've got public static void print persons with predicate. We send in a roster, which is a list of people. We send in this predicate, which is the tester. And we say, okay, for this entire list, if tester.test, so if this predicate we sent in .test, which is the name of the method, if it returns true, then we print the person. Okay, so this is basically a way of just sending in the implementation to print it out. All right, so it checks each person instance contained in the list parameter whether it satisfies the criteria specified in the predicate parameter tester. If the person instance does not satisfy the criteria specified by tester, the method print person is invoked on the person instance. Instead of invoking the method print person, you can specify a different action to perform on those person instances that satisfy the criteria specified by tester. You can specify this action with a Lambda expression. Suppose you want a Lambda expression similar to print person, one that takes one argument, an object of type person, and returns void. Remember, to use a Lambda expression, you need to implement a functional interface. In this case, you need a functional interface that contains an abstract method that can take one argument of type person and returns void. The consumer T interface contains the method void except T, which has these characteristics. The following method replaces the invocation pPrintPerson with an instance of consumer person, which invokes the method accept. Okay, so now by accepting it, we are going to be setting that behavior. So now this is called process persons. I would say that the steps that are taking place in all these examples are the code is becoming more general. So we're away from just specific snippets to more generalized code. All right. A lot of the specific examples that we do early on in the course, so back in early August, it's just to start learning the Java syntax, right? We start by learning the Java syntax. But as time goes on, we're interested in not just having Java code that works, but having the most maintainable code, the most generalizable code, right? And this is why we're looking at this code today, okay? So we send in the list of people. We've got the predicate, which we're going to be testing, and then we've got this consumer block that we're going to be calling the accept method. As a result, the following method invocation is the same as when you invoked print persons to obtain members who are eligible for selective service. The Lambda expression used to print members is highlighted. Okay? But what if you want to do more with your members' profiles than just printing them out? You might want to validate the profiles or retrieve their contact information. Now you need a functional interface that contains an abstract method that returns a value. So function interface contains a method apply. This is going to retrieve the data specified by the parameter mapper and then perform an action on it specified by the parameter block. So we're processing persons with a function. We send in the roster. we send in tester, and now we're going to have a function mapper that has a person and a string. Then we're going to have a consumer with, which we're going to be calling block, okay? So loop through all the people. If this test is true, we're going to get the data from this mapper, and then we are going to accept it with the data. So basically, you could get the email addresses for all the members contained in roster who are eligible for Secret Service, and then print it. Because that's a pretty common thing, right? You may need to get email addresses in order to email them to say, hey, can't do it, right? So lots and lots of different examples here, okay? All right. All right, so lots and lots of different examples. Let's right now take a look at let's take a look here at some code I have. All right, let's see. Let's go here to Freer School. And let's go to, where is it? Ah, here it is. Yes, perfect. It's in the right spot. Well, actually, no, now we're a day late. But it's close. So here we have some functional programming on REPL, on Replit. Yes, here it is. Okay. Great. So I really like that tutorial we were going through. I'm noticing we're getting close to 8 o'clock, so I wanted to do some other examples today. But, you know, sometimes you need to reread things multiple times. And I think highlighting that is an important point. You may need to read sections again and again. It's not enough to just read it once or hear somebody talk about it once. This is a course where you've got to do things many, many times. And, you know, I can show you where the material is, but then you really need to find the time to go over things again and again. All right, so let's see. First thing we're going to do is we're going to notice that we have a new import, which is going to be for the stream. So we are importing the stream. And then we're going to, again, work with some data. Today's all about data. So we're going to have this, as a list. And I think this is the first time we've seen this array as list being used in class. So even more new syntax. And now with this, we are going to turn it into a stream. We will turn this list into a stream. Okay. And then we will filter. Right? So the previous example was all about filtering persons. So we had to work with the interfaces, but now we are filtering this list of strings. Okay? So we've got mylist.stream filter, and what are we filtering based on? We're saying, okay, if it starts with C, we are going to map it to uppercase, and then order it, and then print it. Okay? So let's run it and see if the behavior matches with what I just, hopefully in English, said. So we see first is C1. Okay, well that does start with C. And then we see C2, and that also starts with C. And they're both in uppercase, which is what we expected. So they're in order, they're only C's, and they're in uppercase and printed. So if we put a little break here, we could say stop here, and we rerun it. We see stop here. Okay? Okay, very good. So, this is the syntax. You can chain methods together. Hopefully, this is going to be more readable and easier to write. It's definitely going to be shorter. So, we're streaming this list. We're filtering. What does this S mean? The S just means any data point, right? Like anything within this list, we're just calling X. We could have called it X. Okay, we could rerun this with X and it's no problem. It works just fine. It's not the S that gives it any significance. See, it still gives us C1, C2. It's just the point that this is a placeholder. S or X is a placeholder to cycle through the data and do stuff with it, right? Like we can sort it, we can make it uppercase, we can print it with for each. All right, let's look at another one. So here we're going to have a stream of A1, A2, A3. And then we just want to find first. And if we did find the first, we just print it out. That's why with A1, A2, A3, find first gives us A1. Okay? Now we're going to look at another way of working with data. Int stream range 1, 4. For each, we just want to print them out. Well, the first number is inclusive, the last number is exclusive. So it's going to print out 1, 2, 3. Then we have arrays.stream, new int I, 1, 2, 3. Now we're going to map n to 2 times n plus 1. And then we're going to average them. And we're going to say, all right, if you could average them, if it's present, just print it out. So we have 1 times 2 plus 1 plus 1. So let's see what that would be. 2 times 1 is 2. And so 2 plus 1 is 3. And then we have 2 times 2 is 4, plus 5, 3, 5, and then 7. So 3, 5, and 7 averaged gives us 5, because that's the number in the middle, and then it prints 5 in the middle. Okay? So lots of different code examples for us to look at today. We can put this one in here. Right? If present is a terminating method. Okay? There's nothing else you do after this if present and print. It's just done. Others that you can chain, like mapping, you can map them in different ways. And we've got average and then if present. So I have some good links here for stream tutorials. And we see here is a good stream tutorial. All right. This example-driven tutorial gives an in-depth overview about Java 8 streams. When I first read about the Stream API, I was confused about the name since it sounds similar to input stream and output stream. But Java 8 streams are a completely different thing. Streams are monads, thus playing a big part in bringing functional programming to Java. In functional programming, a monad is a structure that represents computations defined as sequences of steps. A type with a monad structure defines what it means to chain operations. That's what we were just doing, chaining operations. or nesting functions of that type together. Okay, so reduce, collect, and flat map are covered in detail in this tutorial. And you see where I got my examples from, right? I got the examples from this tutorial. Being able to read through tutorials, I feel that's the goal of this class, right? Now, you could read tutorials without me, but I get messages on Discord all the time, right? If I showed you my message history, you'd see students write me messages all the time. They say, I'm stuck here, can you explain this, can you explain this? There's great benefit in having a competent guide to this process, right? So I think a formal structured school environment like this at Miami-Dade is very beneficial. Now, for most of Miami-Dade's history, my words to you would come inside of Miami-Dade property. Most mobile instructors through MDC Live are using Microsoft Teams. I decided to use Discord. But in the end, it doesn't matter. If my words can get from this point to you and you're hearing them, then it would be the same whether you're inside the classroom or you're in your home or wherever you are, right? Like you're in a car going to an airport. It could be anywhere. Hopefully you're not the one driving. That would be the scary thing, right? Especially if you're like looking over and trying to type examples. So, you know, we're using a corporation's service, their platform, whether it would be Microsoft or it's Discord. Actually, Microsoft wanted to buy Discord. You're getting the information, which is what counts. But why does all this discussion matter? All this discussion matters because it's really on you when you're taking a programming class to find out, am I able to follow this information? Can I actually do this, right? And you figure that out by trying it. Like, I've talked a lot today. I don't usually like to talk this much because I know people get bored with just talking. But there's definitely a lot to explain today. So we needed this time. And CodingBat does have functional programming examples. So you will be able to get your hands dirty with these CodingBat examples. Now, CodingBat has had examples for so many different things up to this point. They've had examples for conditionals and logic and strings and arrays and on and on and on, right? As you're doing these examples, you should be logged in so you can keep a record. Okay, did I do this part? Did I do this part? Did I do this part? Maybe you've got a perfect photographic memory and you can remember everything, right? That's not most people. Maybe you solved it one way the first time and a different way the next time, and it's kind of cool that the site records how you solved something. Now, I don't recommend redoing problems again and again, and hopefully you're going to remember at some point if you did a problem in the past, right? It's not hopefully always new each time you see it. Like, there should be some recognition at a point. But this is a great tutorial. And to sum it up, all this discussion, I think being unafraid to tackle tutorials is a great goal for this course, right? And the main way I'm going to see if you're not afraid to tackle tutorials is you will get a chance to do a final project in this class of your choosing. And to complete this, you will most likely need to refer to tutorials. Okay? So pretty soon I'll have you post your idea, but not right now. But I just wanted to remind you that that is coming. Okay? All right, so then we see this is the next example that I did, and this is the next example that I did, and this is the next example I did. I basically just took examples from here because I think it's a really good tutorial, but they have so many different examples, right? On and on and on and on. So this is a huge study, right? We're just like cracking the surface right now. Here we see we've got a list of foods. This kind of brings us back to our earlier one when we had a list of people instead of the usual strings. And we're going to say, okay, for each one of these foods, we've got int stream range, and then we're going to add a bar. So now we have 3 foods, each that has 3 bars. All right, 806, let's now move on to coding bat functional programming. Okay. So here we see functional 1. Functional mapping operations on lists with lambdas. See Java functional mapping for an introduction. So Java functional lambda code is kind of magical, able to solve certain problems with just 1 or 2 lines of code. Replace all method. In general, mapping is a strategy that starts with a collection of items and runs a function on each item individually to compute a new value for that item. The Java replace all method is an easy way to do mapping. As a first example, we'll use the doubling problem. Given a list of integers, double each integer in the list. Here's a mapping solution. So we have doubling with a list of integers. We're going to replace all. N is going to be replaced with n times 2. And then return nums. Okay? So this little snippet is that function in Lambda syntax. Take in a number and return it multiplied by 2. The first n is the parameter name, followed by the arrow, and then the expression for the new value. Lambdas can be more complex, but they work great for simple little functions like this. The data type, integer in this case, is determined by the lambda's context. Okay? So let's go back here to our first example. And the first example says, given a list of, let's erase the answer. Given a list of integers, return a list where each integer is multiplied by 2. Now they give you the functional API over here, okay? They give you the functional API over here. You've got map, filter, collect, and we're going to figure out how to turn this list of integers, which is called nums, into a doubled list. Okay? So we've got replace all, we've got remove if. Okay? So let's see if we can figure this out here. Let's see if we can figure this out. So we are going to return nums, and then let's see, replace all, and we'll say n to n times 2, and let's see if that works. No, that doesn't work. Okay, let's see. This. All right, so that definitely wasn't it. So let's go back here. I thought that was too short. So then we're going to say replace all. And then we are going to collect it and send it to a list. Yeah, that's probably what we're missing. That's probably what we're missing. Okay, so we go back here, then we say collect all to list. Void cannot be dereferenced. Let's see. Let's see. What do we have here? What do we have here? Replace all. All right, so, oh, you know what? We forgot to stream it. Oh, of course. Of course. Yes, yes, yes. We didn't stream it. So we've got a stream now. Okay? And let's see. But they are calling replace all on the list. So boy. I mean this is mapping it. But I wanted to use the replace all, but yet I'm okay, let's try it with the replace all. Okay, okay. Instead of okay, I've got an idea. I keep going different approaches, but let's just do it one approach and see if we can get it. Nums dot replace all n to n times 2. All right, and then return nums. Let's just try this. Yes, okay. So why did I make that so ridiculously difficult? I don't know. My brain wasn't working for a minute. So I was combining different approaches. Okay? I was combining different approaches. I was making streams and lists, and it was just crazy, right? But when it comes down to it, what are we doing? You have to step back and say, what are we doing here? Replace all runs on a list, okay? Replace all runs on a list. So if I'm doing something like turning it into a stream and then running replace all, then it won't work, right? That's ridiculous. So you have to run replace all on the list. Now, inside of replace all, what are we doing? Well, before we said we need a placeholder, and it doesn't matter what letter you use. You want to use S, you can use S. You want to use N, you can use N. Fine. So for each element inside there, for each S, what we're going to do is we are going to replace it with S times 2. So we used to have 1, now we have 2. We used to have 6, then we have 12. And then, after doing this, you return nums. Now, the first time I logged in to this, I had this ridiculous solution. All right? So this is the cause of my confusion. Because the last time I did it, I did this much longer solution where I turned it into a stream, and I guess you can run replace all on the stream. And then you collect it, and then you collect it to a list, right? Now, this, to me, is not as nice as this. I prefer this approach, right? So I'm happier with this, what we did today, than what I did last time. But part of the thing was, as I was typing this solution out, I was thinking it needed to be longer because that was the thing I first saw. All right? But they do give the functional API so you can look through and try to work with these different things. But this is where you're really going to get the opportunity to try things out. So hopefully the discussions about S being a placeholder, about what these streams are, hopefully the first hour of today's class gave you an introduction to this. And now you'll be able to jump in. So let's look at the next problem here. Okay, And now I'm not going to keep talking through this. I'm going to mute myself pretty soon, and I'd like you to solve this. So given a list of integers, return a list where each integer is multiplied with itself. So give it a try, and DM me your solution. All right, well, let's see. Okay, nobody wants to take a shot at this one. So given a list of non-negative integers, return a list of those numbers except omitting any that end with 9. So we're going to need to say functional API should be open so we can look at it. And now we're going to have remove if, okay? So we say here nums.remove if. We want to go through all of them, n, and we're going to say omit any that end with 9. So n modulus 10 equals 9. And then return nums. And we run it, and we see it's all correct. So once you start getting the pattern, it should be a little bit easier. So why does coding that do so many if you just are doing a pattern? Well, the reason why is just to solidify the concept, right? This repetition is to solidify the concept. And it's real easy to get yourself confused. I mean, just think if you want to replay the video of me first making it a stream and then running the replace all and then doing this and then that, like, it's easy to confuse yourself with this. I didn't learn functional programming when at your point in learning programming, because I'm older and it didn't exist. Right? That's as simple as that. There may be a new programming paradigm, as I'm sure there will be in the future, and then you're going to hear about it and you're going to say, oh, this is different, this is unique, and you're going to have to slowly learn it, right? So for me, years and years, I didn't include lambdas on the syllabus. Now, if you look at the course competencies, right? The course competencies don't have lambdas. I just added them because I think they're interesting and I think they're important, right? But I definitely think that there's good benefit to doing it. So let's see. Let's do one more and then we'll call it a day. So give this one a try and then DM me when you're done. Okay, so class gets out at 8:40, so we're almost finished, and we have a pretty easy assignment on Memer. Let's take a look at it. It's actually not related to. It's not related to um, streams or functional programming. It's just about a simple math program where you let the user add two numbers or subtract two numbers or multiply two numbers. And I think you'll find it's pretty easy, but you know, you you do have to like, put the effort in and do it. And then if we go here to Freer School and we look at Java MDC and we go down to this date range. Okay. Um, okay, hide this, hide this, hide this, and then let's look here at this. Actually, the easiest thing would be if I just copied the previous code review. That'd be the easiest. let's duplicate this one. And then we'll move this down here. All right. What week is this? It's 9, 10, so week 11. And go here. And we can also put try some of the functional problems from here. And we can go to career school, we go to Java, go down to functional. Yeah, here it is. All right. All right, so we go here and we save it as the 7th, November 7th. Great. Okay, so now we have everything up and ready. So it is this problem I was just telling you about, math practice. And then this week has the code review week 11, where you are going to just solve from Code Wars. And I say try some of the functional problems here. And I have a link here to Java multi-line functions, right? And they just give some cool examples here. So I think that would be fun if you were able to get that working. But if you want to solve other problems, that's fine too. As long as you solve two. As long as you solve two. Okay, so it is 8:40, and I took attendance. So hope everybody has a great day, and I'll see you on Wednesday.